Hi, I'm Rashmi Krishnamohan, and today I'm going to walk you through a really fun project that I did where I analyzed the Spotify dataset using SQL. And this one's pretty special or cool because it's a beginner friendly, very beginner friendly, but also gives you room to play with some more advanced SQL techniques if you are interested in the future. You can include more KPIs or advanced functions like window functions, and you can use the same data set and build your portfolio with this. Whether you're new to SQL or just want to build a portfolio project, you can speak into about it in the interviews, and this is a great one to do that because everyone likes a Spotify dataset because it's a pretty complex, beginner friendly. I don't know, it's a mix of both. So yeah, we just get started, and I grabbed this data set from Kaggle. It's a data collection of data where you can download any data domain that you're interested in, and you can build projects. And this is a very cool tool to use. I'm just going to paste the Kaggle link where you can download the data set from in the chat box. And I'm just going to, if you could go to the Kaggle website, I'm just going to navigate it right now. Wrong one. I want to do it in my Google Chrome. So this is free for all users. You just have to create a login if you don't have one already, and it will allow you to download any dataset as I mentioned. Now, right now I have the Spotify dataset with me, and if you go on Chalk, there is a download button, and you can just click on download over here. And you can download it as a zip file, and then you can extract it in your file explorer. Just gonna create a new folder. I've already downloaded it, so I'm not going to download again. So you can download it and then extract it in the file explorer, as I mentioned. And you can open SQL Server Management System, SSMS, or you can use even PostgreSQL for this. I would recommend not using MySQL for this Spotify dataset because it's a pretty huge dataset, and only SQL Server Management Studio and PostgreSQL might work easier. MySQL might throw an error if it's a very large dataset, it doesn't support that often. So we are going to work with SSMist for today's session. So I'm just going to create a new database so that we can create from scratch for any beginners who are watching this video. And um, yeah, so I just right clicked on the database and I pressed on new database, and I'm going to give a new database name, maybe like a Spotify, and then click on OK, and it's going to create a new database for us. So as you can see here, the database is created, and I'm just going to click on this and click on new query. We already have it, but still, it's pointed to a different database. I'm going to close this one, and right now, what we can do here is we can start by exploring the data set first. Now that we have it all ready, we can just start with the Excel exploration of the data, and then we can move on to how to import the data set over here into our database tables. So I'm just going to go to my Spotify folder that I just downloaded, and it's called Clean Dataset that you just extracted from Kaggle website. And let me, maybe I'll just extract it again just in case if people wanted to see how we could get that. Just a second. Okay, you can just click on this and click on extract all, and it would create a new folder for us. As you can see, we have the clean data set over here, and let's open it and we'll see what columns we can work with and how the data looks like. I was just explaining about how we downloaded the data set from Kaggle. If you see in the chat box, there is a link to Kaggle website. and we downloaded the Spotify dataset from there. And I'm just starting on the exploration of data in our Excel first, just to catch you up on that. Okay, so these are the columns that we are going to work with today. So as you can see, we have artist, track. So each the artist is like the whole person who created the record or owns the record, the track that they published, the album. It might be a single album or an album itself. And we have various metrics, as you can see: danceability, energies, loudness, speechness, acousticness, instrumentalness, liveness, and balance, tempo, etc. These are, we can take an average in order to analyze these columns. And then we can do like a top 5 or top 10 metrics based on the KPI list we have. And then we have the duration minutes, how long the song is running, or what's the maximum time that the song is for. We have the title for the song, the channel, and these are very important columns: views, likes, comments. We are going to use this a lot today. And then we have licensed. So licensed meaning if the album is licensed or not. So we have like a Boolean column that's true or false over here. And then if the album or the track has any official video, again, it's again a Boolean column, true or false. And then how many times that particular video was streamed. And then the energy liveness, another metric that we could use. And then most played on is the last column. So I think we can see what we have over here. I think it has two, just Spotify and YouTube. So Spotify, YouTube, so it just have we can analyze between how many times the album or track was played on Spotify and on YouTube. So this is a glimpse of the data set that we are going to work with today. And we're going to import this data into our database table. This is for beginners, so I'm going to show you how we can do that. As a data analyst working in a real work environment, how we could do it. We would use like a bulk insert function and then do a very simple ETL where you could like make some data type transformations or even replace some leading and trailing spaces, etc. And then we can analyze the set of KPIs. So we have 5 easy level KPIs, 5 medium level, and 5 advanced level. And I'm not going to cover all 5 advanced. I have 2 questions as a take home. If you guys are interested, you can solve it or try to solve it on your own. But I do have the solutions to all these in my GitHub profile. If you are having any doubts while um, you're trying to solve this, I will paste the link to my GitHub on the chat box at the end of the session. I hope that's good. I think we'll get started on the SQL side of the project. Okay, as in the beginning, we just created a new database called Spotify. And then now we are just going to do what we are going to do is we are going to put these data set into a staging table, and then the staging table is going to make all the columns as the same data type, and then we can do a simple ETL in order to change the data type as we want, and then so that we could have this as a resume. You can add this project to your resume to show that you know how to do a simple ETL process. That's why I just wanted to include this step without doing any direct. We can just do it directly here too, like click on the database name and then task, and then the import data from here. But this is not how it works in a real work environment. This doesn't work like that. That's why I wanted to include this bulk insert function. Okay, let's get started. Um, so as you saw, I already did this particular step because it just takes a lot of time to type this during the call. So I just wanted to do this. So this consists of all the column names that we just discussed, that we saw on Excel. And then I just made it all as one data type, as I mentioned, varchar. So it is all going to make it as a string, but string doesn't work in a database. We have to change it to, like, for example, it might be a float or a Boolean, can be a bit, or these title, channel, or artist track, it should be a varchar itself. And then other stuffs like acousticness, instrumentalness, liveness are all going to be a decimal or a float function. And then the Boolean ones are going to be bit, right? So well, I'm just going to create this. We always use drop table if exists because once if you're rerunning it again and again, ETL means you don't have to run it once. You might have to run it again and again in your everyday life. So that's why I wanted to create include this particular drop table if exists. If you want to follow along, I just pasted the query in the chat box. You can do it as we speak, and you can practice along with me if you're interested. So we have created a Spotify staging table. And then what we are going to do now is do a bulk insert so that the CSV file, which is currently in our desktop, it can be loaded in directly into the database table. All right, so let's do that right now. Bulk insert. So I'm going to insert this into this particular table, right? So staging table that we already created, just the table structure we created right now. And I'm going to do a from, and here I'm going to go to the file that I just extracted from the zip. And then I'm going to include this file path over here. Okay. This is a syntax. So bulk insert the staging table name from the file path with. So we're going to give some parameters over here. That's it. This is a universal syntax that you can use. You can even have it with you saved as a sticky note and you can use it again and again. This doesn't have to be memorized or anything like that. It's available on the internet as well, Stack Overflow, ChatGPT, anywhere. So you don't have to worry about the syntax to know it like by heart, right? So field terminator. I'm going to explain what these are in a minute, but I'm just going to type it right now. Field terminator, row terminator. It's going to be the next line, and then I'm going to make this very simple. I'm not going to add any extra columns or anything like that. That's it. We are done. So, oh, there should be a command. Okay. So field terminator is nothing but every CSV file. You're not working with Excel, right? So CSV file has some delimiters. So once you're opening a CSV file in a notepad, you will know if it's a comma or semicolon. In our case, it's a comma. That's why I put comma over here. That's the field terminator. The row terminator is /n. That's the next line. So each row is like it breaks using a next line. So that's why we have the /n. And then the first row I gave as 2 because the first row has headers. So we're going to start inserting only the rows from after the headers. So that's why I have included this. I'm going to try running this. It might throw an error. I'm just going to run it and see. Oh, yeah, I have it open in my Excel. I should close it. It doesn't work if I have it over here. There. Okay, so there is an error over here. I'm just going to debug it. Okay, it worked. Okay. I don't know how it worked, but it worked. Okay, so it did insert all 20,594 rows that I just saw in the Excel file. So I'm just going to quickly query this out. But one thing that we need to be very careful with here is since we are using comma as a field terminator, we might have to go ahead and check all these character files in Excel. If it has any comma, it might push or it might push it to a different column. So we might have to, try to remove any commas in our Excel file. And also, some of the tracks might be a numerical value and the numerical value, if it is a number field, then it might have a comma, like 96,000 can be a comma instead of a album name can be that. And then the uh, Excel actually automatically includes a comma over there. So we are going to fix that. We are going to try running it one more time just to be safe. We didn't throw any error, but I can't sleep at night if I know that I did this mistake without doing my manual cleaning process. So that's why I'm going to do that right now. I don't want this. Okay. So as I mentioned, I'm going to click on find and replace. Oh, uh, there isn't. I mean, there is something called import flat file, but it doesn't work like that in a work environment. As I mentioned, you have to have like a bulk insert so that you can make that file path dynamic. If you're working with a lot of files, you have to, you can have it as a dynamic value and you can, replace the file with different file paths and files. So that's why we are going with a method that is more common in use in a workspace. I hope that's clear. Um, okay, where was I? Yeah, we're going to find comma and replace it with, I don't know, maybe a dash. I don't care. I don't know how, like, I don't care how it's gonna look. So I'm just going to replace it. And this does not have any duplicates. I checked. So it's a very clean data set that way. And I'm just going to make my text columns as general, just to be sure. I don't know, it's already general, but I just wanted to make sure it's general. Okay. Title, channel, and yeah. Oh, I think one more is most played on, so I'm going to make it. Okay. I think that's good. I think so. And my file does not have any commas, so we just fixed that as well. So I'm going to rerun my code one more time. If you want to follow along, I just pasted my bulk insert code in the chat box as well. Um, okay, let's see now. Okay, I think we're good for now. If something throws an error in the future, we can try to fix it during this call as well. Okay, now that we have it all as a varchar, we need to change it to a simple ETL process in order to make it a proper data type for each column. So that's what we are going to do. Um, I already created this one. It saves some time during today's call. So what I did was I made artist track album type as varchar. I did the danceability, all these metrics with a float or decimal number as float directly. And obviously the duration minute is also a float number. And again, the title and channel, it's a varchar, the title of the song and the channel name. Again, the views. Uh, why we got as big int is it's a very big integer. Integer, if we put integer, it's going to throw an error that it's going to truncate the value or something like that. That's why we have it as a big int. Same goes for stream. I want to make float as big int as well, but that's okay. Stream is also a big int. If it shows something like blue, we can make it a column name, proper column name by adding a braces at the end. And then the energy liveness is again float. Again, the most played on is a varchar. That's Spotify versus YouTube. All right. So we're going to create another table called Spotify with the correct data type, and then we are going to do the ETL now. So the ETL, how it looks is, I'm going to paste it here, and then we'll discuss what this means. All right. So I'm going to do an insert into these particular column names. All these column names are, this is the syntax for insert into statements. And what I did was my CSV records all had reading and trailing quotes. It's a quoted text. So I had to replace it with null. So it's going to say it's going to search for double quotes and it's going to replace it with nothing. And I'm going to do that for all my text data types, the string data types columns. And then the other ones, I'm good with decimal or I'm going to go with float. And I'm going to change my license and official, the Boolean ones. So wherever the license is true or one, it's going to replace it with one. Else, it's going to replace with zero. So instead of true or false, we're going to work with one and zero. The same goes with official video. If it contains true or one in that particular column, it's going to replace it with one or zero. And we did the same. We changed the data type to big int, and then we changed the energy liveness to decimal, and then again, the most played horn had a leading and trailing space. So we had a trim over here, and then we replaced the double quotes with nothing. So this is a very simple transformation ETL, nothing major. I didn't cover any aggregated transformations or ETL process because, as I mentioned, this is a very beginner friendly workshop. So that's why I just stuck with this one. Right. Now that we have our So what we did was we created a staging table first with a column names all having the string data type, and then we bulk inserted the CSV onto the staging table, and then we created the main final table, and then we did a simple data type transformation ETL that transformed the data from staging and put that into our final Spotify database, I mean database table. So this is the table that we are going to work with for all our KPIs. Uh, I hope that's clear so far. And we used one more thing I wanted to mention was we used TriCast. We don't use cast. Cast would try to change all the records as a decimal, but if there are any values that doesn't like doesn't allow the SQL to turn it into decimal, then it will show an error. But TriCast would try to cast that particular record as a decimal. If it is not able to, cast it, then it would become a null value, right? So that's why I'm using TriCast and not cast. You can use all these example if you are going to an interview. You can actually use. We are going to use Scola's function as well in a few minutes. So you can use all these. It's a very simple thing. You might not use it during your interview prep, but when you're doing a project like this might be a very interesting thing that you can actually talk about during interviews, and it would show you like stuff about how to handle SQL errors or SQL transformations. That's why I wanted to include TriCast here. Okay, so I think we're just going to do a quick exploratory data analysis to see what we are working with. If we want to do some more transformations or error check, we can do it over here and then rerun it as we go, right? That's why we are doing the drop table if exist. Because if you're rerunning it again and again, it's not going to create duplicates. It's going to delete the table and then refresh the code with the new data set. Okay. Uh, so what I'm going to do here is I'm just going to do like a quick, I'm going to do a count star, like how many values I'm working with. So 41, 41188. And then I want to see how many distinct artists are there in this. Hmm, spelling mistake. Yeah. So we have about 2074 artists, and I will see about album. And we have about 11,798 albums. And what are the album types? Like there might be a single, oh, not count. I want to see the actual distinct value. So we can see the album types that are in the particular data set that we are working with, compilation, single, and album. So let's also see one more thing. Start from Spotify. So there is something called duration minutes. I want to see the maximum duration maximum duration for the song, and then same for minimum as well. Let's see. There is a song with 0 minutes, which is not right. Let's see which song it is. Oh, sorry, where duration minutes equal to 0. Hmm. That's not right. We have four fields actually having, I don't duplicates and also have 0 duration minutes. I think we can delete this, right? Do we have? Yeah, I think so. Okay, let's do this one more. I don't think this is right. Okay. Yeah, it should be two. That's what I was thinking. There was duplicate. I think we ran it twice by mistake, and I think we are good now. Okay. We have like two albums, two tracks, which are having 0 duration minutes, but it still has views, likes, and comments. It's not possible if there are like 0 minutes for the particular song. We can actually delete this particular both these two records because it's not going to be of any use when we're doing the KPIs. So delete from the Spotify where duration minutes equal to 0 is going to delete the two records. So I think we are good here. Do you have any questions so far? Because we are going to move on to the KPI list.
No, I'm good.
Okay, awesome. Thank you. Thanks for confirming. Okay. In that case, let's just get started with this particular list. We are at 6:35, so we have about roughly 1 hour. I want to say 1 hour. So, okay. We have, these are very basic, easy level questions. We're going to tackle this first and then we can move on to the medium level questions. Oh, wrong tab. Okay, I'm just going to create a new query. I don't want to. Okay, I'm just going to do this. Okay, retrieve the names of all tracks that have more than 1 billion streams. So we'll always start with querying the data so that we know what columns we can use. Always start with this. And they're asking for the names of all tracks. So obviously we're going to select track, right? And we're just going to use a simple var clause, right? Where we have the stream, we have a column called stream over here. So we're going to use it. So stream equal to, if it shows this way, right, then that means the data is not still refreshed, that the SQL does not know that this data or table are being created. So we can just go to query and then click on IntelliSense. It's going to refresh it. So now you have it, no red lines, squiggly lines over here. So that's a bit okay. So they're asking for having more than 1 billion streams. So it's not equal to, it's greater than. Billion means 9 zeros, I guess. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So we're just going to see. So we have about 385 tracks that have been streamed for more than 1 billion times. So this is a very simple KPI. These are all simple, easy level KPIs. The
Well,
next, yeah.
so I have a question. Will this take into consideration if there's any duplicate tracks in there? Will it like relist those duplicates or not?
Yes, as I mentioned, this data set has no duplicates. We checked already, but
Okay.
yeah, if you are still not sure, you can actually do a Control A, go to data, and then click on remove
Yeah,
duplicate.
yeah, true that.
Yeah, and then make sure that you have all the columns selected and then click on OK. That's it. But it does not have any duplicates. But if you're still want to do that, you can do a
But
distinct track.
well, I guess my question is more like if there are duplicates, will this reflect those duplicates?
Yes, of course,
Okay.
because we didn't use distinct before. If you're
Okay.
using distinct, it would not include duplicates.
Okay. Thank you.
Okay, perfect. Now we have the next question. So list all albums along with their respective artist. Again, simple question. So if you just want to select, start from the database again. And then we have what columns we can use is album and artist. Where is that? Yeah. Okay. And then you can actually order it by a certain album name. You can use one, or you can even use the alias name or the column name directly. It works the same way. All right. I hope that's clear. And you can do a descending, ascending. You can do whatever you are like asked for the requirements. All right. Get the total number of the third one. Get the total number of comments for tracks where licensed equal to true. As we already discussed, we actually changed all the true to one in the ETL step. So we might actually have to make the var clause as licensed equal to one. Um, so yeah, let's do that. So select start from Spotify, right? So licensed, as I mentioned, it's 0 or 1. So I'm just going to say licensed equal to 1. So what they're asking for is total number of comments. So it's going to be sum of comments, right?
Makes
So
sense.
that's the total number of comments. So you can give like an alias name to actually give a proper column name for your report. Okay. Yeah, that's the total comments. We have about 4.9 billion, I guess. Are we good? We can go to the fourth one, or feel free to stop me at any time. I am not able to see the Zoom chat at the moment, but if you have any questions, feel free to unmute yourself and ask anytime. Okay. And the fourth one is find all tracks that belong to the album type single. So, hmm, they're asking for the tracks. So obviously we're going to select that, and then the album type we are going to use a var clause. We already did like an EDA on the album type, so we had like three types, right? So album type equal to, oops, yeah, single, and we're going to find all tracks. So we have about 4,973 single tracks. Um, these are all very simple questions just to get familiar with the where clause and stuff like that. Okay, the last one in the easy level KPI list is count the total number of tracks by each artist. So this is where the group by comes in, right? Again, we just start with a simple select star from Spotify to see the data set we're working with. Select star from Spotify, it gives like what they're asking for is tracks by artist. So obviously we're going to do select star by both artist comma track, right? So they're asking for total number. So we are going to do a count on this track. Total number means count because it's a string. We can't do a sum. Track is a string or character type column. So we're going to do a count on it. And I'm going to give an alias name like number of tracks from Spotify, right? And then we're going to group it by this artist. So that for each artist, it's going to count the number of tracks, and we are going to get the result for each artist. As you can see, each artist has about 10 tracks in this particular data set. So I'm going to order it by just to see because it's all like 10, 8, 10. So I don't want to see it by this particular. You can either use two or you can use the count of track itself in the order by. and then click on descending for us to see like highest to lowest. So almost most of them has about 10 records. Let's just do ascending. So if you're not giving anything for order by, it's going to give ascending by default. So some of the artists has only one track, some of them have five, six, seven, eight, but most of them have about 10 tracks. These are all the easy level KPIs. Do you have any questions so far, or we can move on to the medium ones?
I'm good.
Okay, thanks, Jane. Okay, let's do the medium KPIs next. Okay, so this is where the average and everything comes, like all the metrics that we saw in the data set. It had like a various danceability and stuff like that. So we'll do the first one, calculate the average danceability of tracks in each album. So what this actually gives or asks, they're asking us to analyze is like to tell us, to tell them how suitable a track is for dancing. Maybe some stakeholder is asking for this KPI, and that's when they ask like, what's the average danceability for tracks in this particular album or in each album? So when some stakeholders come to you and ask something like that, that's when you are going to use a very simple or medium level KPI like that. Okay, let's start with the same. So let's start from Spotify. Okay, now we are going to use, they're asking for album and track and the danceability, right? Maybe it's like the danceability of track, so it's going to be for each album. So I think it's only for albums they're asking. So I'm going to do album, and then we have the danceability column. So we're going to do the average of danceability, and I'm going to give an alias name, right? So obviously we are going to do a group by any aggregate function, sum, count, average, or anything like median. There's no median in SQL, but they or any aggregate function, it has to be accompanied with a group by clause. So any value, any column that you're adding other than the aggregate column must be included with the group by clause. Okay, and I'm going to run this one. So it does have like some average transferability. I'm going to order it by two, or you can even do the average transferability. Either this works or this works. Either of this, they are both correct. So since this is ascending, I'm going to do the other one. Descending, it makes more sense. So for Certain and Funky Friday, they're all having great danceability tunes, I guess. So they're all in the top. They might even ask us to get the average danceability of all albums and maybe give a threshold. I want to see the albums which have danceability greater than the average danceability of all albums. For example, if the average danceability is zero point 0.5, they want to see the list of all albums that are greater than 0.5. So these are like a starting step. So we're going to cover that in a while, but this is like how we can work with these type of functions.
Did I ask a question?
Yes.
Why do we need the group by album in this case since we're already selecting album?
Yeah, so for example, right, this is a syntax. So this is a aggregate function, right? Any
Yeah.
function, any column that is accompanying with aggregate function, it needs to be in if not, it will throw an error. This is syntax.
Okay. Okay.
Yeah,
Gotcha.
so the Spotify.album, the one that is not an aggregated one, it's invalid in the select list because it is not contained in the group by clause. So it
Uh,
must be in the group by clause.
okay, I understand. Okay.
Mm. Yeah, good question though. Okay. So we are good with, we have completed this particular medium level question. I hope this is still clear. We'll move on to the next one. Find the top five tracks with the highest energy values. So this one asked us to find average, highest meaning max. They're asking us to find the maximum energy value, and they're asking us to do only top five tracks, right? So we'll just start with same Spotify. Okay, so we are going to use the, where is it? Huh, energy. This one. The energy column and obviously the track column, right? So again, max is also an aggregate function. So the track, comma, max of the energy. So the group by should have the track column, or else it'll throw an error. So track, comma, max of energy as highest energy from Spotify. So group by track. So this is an aggregate function. Any column other than the aggregate function, it must be in the group by clause. Okay.
And yeah, that makes sense. Thank you. Yeah.
Yeah, no worries. Okay. I'm going to do this first and then we'll do the top five in a while, okay? Okay. So we do have this, but since it is all jumbled or not in a correct order, I'm going to use a order by clause. I can use two because this one is the first one. This is the second one. So I want to order it by the second one. That's why I'm using two. If you want to order it by track, I would do one. Okay? Or you can directly use the aggregate function in the order by clause. Anything works. So this is an ascending order, but I want to do descending. So I'm going to do descending. So they are having like one as highest energy level. All the tracks from this Rain and Thunderstorm album is having the highest energy level, and then the gentle piano melodies. Since they're asking for top five, I'm gonna do top five. If they're asking for top 10, you can do top 10 as well. I'm just gonna do top 10. Just it's all one, doesn't make sense. So yeah, my bad. Okay. Uh, so top 10, these are all the tracks with the highest energy level, top 10 tracks. Okay, I hope that's good. We'll go to the third one in the medium level KPIs. List all tracks along with their views and likes where official video is true. Right? This is a Boolean column that we already changed to 1 and 0. So let's see how it looks like first. Where is it? Official video. So if the video has an official video that's true, then they want to list all tracks along with their views and likes. All right. So obviously we are going to use a var clause first. So official video equal to 1, right? And they want to see how many views and likes each track or all track had. So obviously I'm going to do track. I want to do it by track. And then I want to do sum of the views column and then the sum of likes column, these two columns. Right? And again, these two are aggregate functions. Anything, sum, average, mean, max, min, everything, it's all aggregate. So there should be a group by clause. And then we have the one thing that's missing, that's track. And let's see how it looks. Mhm. So I want to group order it by, this is 1, right? This is 2, and this is 3. I want to order it by 2 and 3. So 2 descending, both descending order. I want to see both the maximum values, right? So Despacito track had about 1.6 billion views and 1 billion likes, and See You Again by Charlie Puth had about 1.1 billion views and 80 million likes. Yeah, these are maybe you can also do like top three tracks, top five tracks, anything. If the stakeholder is asking you for a particular, you can easily customize your query according to their requirement. This is a top five track which had most views and most likes, which had the official video. I hope this is clear. We'll move to the fourth one. For each album, calculate the total views of all associated tracks. They're asking us for total views means sum of views, and then there we are going to group it by album and tracks. It's very simple from the question. We can already see where we are going with, right? Okay. Again, as I mentioned, I'm just going to do album, tracks, and then sum of views. Again, sum of views is an aggregate function, so I might need to do group by for the other two columns. Oh, I want to use an alias, right? Yes. There's no track. Oh, there's no S in the column. My bad. Uh, so let's order it by total views. Descending. Yeah, Despacito again. By album Vita had about 1.6 billion views. See You Again, Lean On, Shape of You, Calma. This is what you came for. This is all very interesting to look at. If you are a major music freak, then these
It
are all.
is. It is. Despacito is big. Wow.
Yeah, I was just thinking the same thing. Also, okay, let's move on to the fifth one. Retrieve the track names that have been streamed on Spotify more than YouTube. This is where we are going to use a little bit more complex ones like case statements. So let's see how we can. So we are going to work, as I mentioned, there is a column called most played on. So it had like two categories, Spotify and YouTube, right? So we are just going to track the names that have been streamed more on Spotify than YouTube. So we are going to compare both the stream columns, and then we are going to use a case statement to split this column into two columns and then use a CTE. I'll share. It's a bit complicated, but I'll share it like how we can go through this problem step by step. All right. So they obviously want the track names. So we're just going to do a track for now, right? And then there is something called case when most played on equal to Spotify, then stream. Okay, it's going to use stream, else it's going to do zero. No, I don't want else actually. I'm just going to leave it for now. And okay. So what I'm going to do here is I'm going to sum the stream. All right. So what it does is case when the most played on is equal to Spotify, it's going to take only the Spotify rows, and it's going to, if it's Spotify, then it's going to take the stream column and then sum it. Okay. And that is going to be our Spotify streams. And I'm going to do the same for YouTube. And so it's going to create two new columns rather than one column for both Spotify and YouTube combined. So I'm going to copy paste this one. And instead of Spotify, I'm going to use YouTube. So case when most played on is YouTube, then stream. It's going to sum all the stream values, and then it's going to be named as YouTube stream column. All right. Obviously, these two are aggregates. I need to use the group by and track. Let's see how this looks. Huh. From Spotify, right? There's a comma over here. See, so as I mentioned, it has split into two columns, Spotify streams and YouTube streams. Wherever the row most played on was Spotify, it summed all the streams and then put it here. And wherever it was YouTube, it summed all the streams and put it in the YouTube column, right? But the null, it's not looking nice and it's not going to be of any use. So there is a function called coalesce. What it does is it makes all the nulls, it takes a first non-null value, so it's going to make the null. Wherever there is null, I'm going to make it as 0. This is a function. So the entire function, I'm going to put it inside a coalesce function. So wherever there is null, this is a replacement value. I'm going to put it as 0. I'm going to do the same coalesce, and wherever there is null, I need to replace it with 0. And let's see how this null is going to change into 0. See, wherever there was null, it's all now 0. Now we can do a comparison like wherever Spotify is greater than YouTube, then I need that particular track name. Since this is already enough data result that I can work with, I can put it in a CTE. It's called Common Table Expression. So this particular result set will be saved in this CTE name. So whenever I query the CTE, this particular result set is going to come for me, and then I can make more VAT clause or even more aggregations, anything I want using this statement. So this is a very efficient way to break down your query into workable chunks so that you can work and explain it easily. There is an error. One second. Oh, there's no from. Hmm, what's wrong? Oh, I did group by, right? Group by track, coalesce. Oh, there is no end. There is an end. As Spotify, from Spotify. I have no idea. Oh, this is the syntax, my bad. With CTE as. So the result set is currently now in the CTE. Now what we can do is we can compare Spotify streams and YouTube streams. So we can use a var clause easily, right? Now we have two columns. Spotify streams is greater than YouTube streams. But YouTube streams, I don't want it to be 0. It's of no use. So I'm going to do and YouTube streams is greater than 0. Not equal to 0. So both works. Both are same. So we have about 185 rows. So we came from 17,548 rows to 185 rows. So these tracks have about like more Spotify streams than YouTube streams. You can even order it by Spotify streams. More Spotify streams. Old Town Road, Remix, Silence, Photographs, Day, Perfect Strangers. They had more Spotify streams than YouTube streams. So Spotify might use this to, analyze every person's track and then make recommendations according to their taste. So this is how the organizations use data to make analysis and make recommendations for future. So I think we're done with all medium level questions. We have I'm going to do three advanced level questions and then we can do the two if you're interested. You can take home and do the um, other two. Okay, let's do the advanced. Hmm. Okay. Find the top three most viewed tracks for each artist using window functions. I hope this one was clear, the medium last one, because we are going to use even more advanced function called window functions. We're going to use dense rank. If you are familiar with it, well and good. But if not, I'm happy to go over it right now. So this is a very, very common interview question. Any interview SQL question that you're going to face, it's going to have top three using window function. You're going to maybe they can ask you top three employees with highest salary in each department. Anything this function is going to work, or this one or row number function, dense rank, all the window functions are actually very common in interview setup. So let's do this one is going to have like a CT again, the same CT that we worked with, and then we're going to also use the window function as requested by in the KPI.
Sorry,
Okay.
what is the window function?
Oh, so there are like many functions like row number. It'll add a new column that inserts a row number based on a particular category or conditions that we are giving. Um, Window functions also include rank and dense rank. It would automatically
Mhm.
add a rank column or dense rank column, which would allow you to get top three results without having any such complicated subqueries. I hope that's clear. Any window, like all the aggregate functions can be made as a window function, even some can be made as a window function using a over clause. There is something called over clause. So sum of something over partition by, this is a syntax for window function. I highly recommend you to look into it in YouTube. But I
Mhm.
will go over the basic ones now.
Okay.
But yeah, I would highly because it's very, very commonly used. It just not even in the interviews, but also in the daily data analysis world. It's very easy to use and very common to use. Uh, so I'm just going to give a basic, what are all the window functions that you can actually use. Row number, oh, rank, dense rank, lead, lag, anything like it all comes with over clause. Like this is a syntax for
Okay. Okay, I get it. I get it. Okay.
this is syntax for the window function.
Right.
So yeah, this is all very commonly used ones. I will paste this in the chat box. If you can refer to it later as well, that's well and good. Actually, very, very useful. Okay. Let's move to this question. Uh, and then we'll try to solve the other ones. Okay, find the three most viewed tracks for each artist using window functions. All right. So we are going to go with obviously artist track and most viewed, so sum of views. So it's all in the question. So I'm just going to do that right. I'm going to view my table quickly just to see I'm using the correct column names or not. All right. I'm going to draw star. I'm going to use the album. No, sorry, artist. Way back. Artist. Track. And as I mentioned, most viewed. So we are going to use sum of views. All right. So I'm just going to run this for now and I'll show you what it looks like so that you will know why I'm meaning that we need the window function to rank this top three. All right. I need a group by obviously. Okay. Let's order it by something for now. Order by 1 and 2, maybe. So as you can see, this particular snot, they have many tracks, and they all have different level of views, right? Each track had different views for this artist. But what they're asking for is they're asking for top three, like let's do three descending. Yeah, let's do it and see. Yeah, they're asking for the top three views for each track, right? So they want to see like which, like for Snot, the top three, for Suicide Boy, the top three, the Giddle, the top three, and Sing top three. But it's very difficult if you just randomly put top three. It's only going to give you top three, and that's it for Snot. It's not going to care about other artist names and other artist values. And that's why we need a window function. So this way, we are going to add a rank for each artist. So it will add a rank for all artists individually. So that's why we're going to use something called rank. So there is also something called dense rank that we're going to use now. I'm going to share the difference why we're using dense rank too.
Mm, okay, I kind of get it. Makes sense.
Hmm. Maybe not. Okay. So this is the, as I mentioned, this is the syntax. So partition by means what we have to partition this rank by. So we are going to partition by artists. That's what they're asking for. All artists, they want the rank. They didn't ask for track. If it's a track, there won't be any rank at all. It's all going to be one. So I'm going to do artist and then order by this sum of views, right? Descending because we need the top three. So highest three ranks for each artist. Let me run this and show. Hi. That's Aaron. Let's see. That's local views. I want the order to be Aaron descending. No, Aaron descending. Sorry. Huh? One sec. I did the order by wrong. Order by should be artist, track, and then Aaron. I don't know why the RN is not coming, but as you can see, this one is one, this is two, and this is three. So these three are the top three ranks or top three most viewed track of this particular person. Same goes for Suicide Boy, 1.7 billion live views.
Mm,
The two is nine point something, and then 3 points. So it
yeah,
provided the rank for each artist based on the number of views they had for all tracks, right? But they are asking for only the top three rank, so that's why I'm going to do up with CT. So I'm going to add this result set into a CT so that I can work with a var clause again. Or else it will be like a nested subqueries. It won't be very good to
correct.
look at or easy to work with. So with CT as CT does not allow us to do order by, so I can't use order by. It will throw an error if I do that. This is just for, sorry. Okay, let's see how it looks first and then we'll go from there. Yeah, finally now it's coming. Okay, now it's coming in the right order. So we are using the top three, right? So we can actually easily very randomly use var clause. So they want the rank to be top three. So it's going to be less than or equal to three, right? You have to run the CT along
Mm,
with the CT query. So it's going to show you only the top three tracks for each artist. Is this clear or should I explain one more
no,
time?
that's yeah, makes sense to me. I get it.
Okay, perfect. Thanks, Shane. Uh, Awesome. Yeah, this is like very, very common. You can use this particular thing for any use case, any interview questions actually. And also I had to show you why we had to use dense rank instead of rank. If you see here for this particular artist 112, these two, peaches and cream, had total views as same. That's why we have the rank as 2, both as 2. If we are using rank, it would also be 2, but the other one won't be 3, it will be 4. The one rank would be skipped if we are using a function called rank. It's not
Oh,
ideal, and that's why we are
oh,
using dense rank.
oh, that's what
So
dense rank. Okay.
it won't include the third one. That's why, see, it only had 1, 2, 2. It didn't include the rank 3 because it got skipped. The next one would be 4. So that's why our where clause did not include that. That's why we are using dense rank.
I didn't know that. Okay.
Perfect. I hope that's good. Okay, we'll move on to the next question. Write a query to find tracks where the liveness score is above the average. I just mentioned it a few minutes back. They might ask something like this because this is a very common thing because they want everything to be above average. They want a trend line to be set like a threshold. It might be average or a median, and anything above they want to look at how many records are above the particular average value. All right. Again, this is going to use CTE function. You can also use subqueries or anything. Um, yeah, this is totally up to you. I'm just going to use subquery. We don't have to use CTE or anything like that or too complicated ones. Let's see how we can. It's very simple, but it can be asked in interviews very, very, very commonly. So we want to find all tracks where the liveness score is above the average. So first we want to see the average liveness score for all tracks. So I'm going to do that first. Average of liveness, right? So average value is 0.19, right? Let's do one more query. Select star from Spotify where liveness is greater than 0.19. Either you can do this, but this is not ideal. So we have about 6,478 tracks that are above this particular average, but instead of this, you can give this particular query directly so that it's a dynamic record. It's a dynamic query. You're not using a static value. All right. This is a way to do this particular. They want to find tracks. You can also use track. You can use like liveness score, not see everything, something like you can just see only the ones on all the columns that only you want to see. Maybe I want to see which artist that track belongs to. And also you can order it by
Mm.
liveness. Yeah. Yeah, this is the way you can do this particular. You can use a subquery in a where clause. Do
Mm.
you have any question?
No, I'm good.
Okay. The last question, we are actually good with time as well. So use a with clause to calculate the difference between the highest and lowest energy values for, and did I record it? Am I recording the session? I think so. Okay. Use a with clause to calculate the difference between the highest and lowest energy levels for tracks in each album. So they already asked to use with clause, which means we have to use a CTE. And then they want to see the highest energy value and the lowest energy value and the difference between these two columns. So we are going to use max and min. And then for each track, we are going to use obviously a group by. Okay, let's do it. Select star from Spotify. They want to see in each album, right? So I want to use album. So max, which one is it? Energy, right? Yeah, max energy as highest. For lowest energy, I'm going to use min function, lowest. And then obviously these two are aggregate functions. So obviously we need a group by clause. So group by album. So we have this, we can actually use the difference in the same query itself, like for example, max of energy minus min of energy, but they are insisting us to use a with clause. That's why I'm going to put this in a CTE. Okay. Select star from CTE. So instead of star, I want to use this album and I want to do a highest minus lowest, right? Hmm. What did I do? Hmm. I'm missing something. Group by album. This wasn't. Oh, it's a comma here. Okay. So there's an energy difference, right? So this is actually why this question is asked is they are using like asking us to analyze whether the album is consistently energetic. So one album can have many tracks. So we are seeing if all the tracks are having the same energy level or if they're having like slow versus fast dance tracks or something like that. So this is why they're asking us to analyze this particular KPI. We can also order it by energy difference, descending. So white noise album had the energy difference of 0.9, blah blah, etc. And that's it. That's all the KPIs I want to cover for this particular workshop. I hope this was helpful, and I really, really hope you guys can actually do these two take-home questions if you're interested. I'll just paste them in the chat box. This also uses window functions and CTs, so this might be a useful way to actually make your portfolio more interesting. You can save this SQL file and then upload it to your GitHub and share the GitHub link in your resume. If you're a junior data analyst, if you're intermediate or senior level data analyst or data enthusiast, you can actually even ask ChatGPT to generate KPI ideas. And then you can work on the same data set and include more advanced KPIs and try to make the portfolio even more stronger for your project or for your resume. Spotify dataset is something very popular among interviewers because it's a real world dataset is actually extracted from Spotify app. So it's not a very random sales data of a makeshift or made up restaurant or something like that. So it's a very interesting data set that you can actually put that in your resume. And I really hope this was helpful. Um, yeah,
Very helpful.
I hope so. Yeah. Thanks. Okay, yeah, thanks. Good. That's good to know, Alan. Thanks for joining.
Awesome.
Thank you so much, both of you, Shane and Alan. Thank you, and really appreciate you following along with me. And yeah, thank you.
Have a good day. Thank you. Bye.
Yeah, take care. Bye.